Hi there. All right, so I am going to make a video here that goes over problems similar to these reflection problems from chapter 1, the ones that maybe you didn't do so great on the test, but rather than doing these on IXL practice, I'm going to go ahead and just do some sample problems with you. Now, here's kind of my game plan. I'm not going to hand you all your answers. I'm going to do a problem crazy similar to the one that you have on your worksheet. So all I've done is change the numbers in it. So I'm going to do my own problem. You kind of learn from that and see if that kind of sparks some memory of how to work through these problems. And then you're going to actually be working through your own problem on your paper with your own numbers. Okay, so here's number 1. It says how many gallons of a 15% acid solution must be mixed with 4 gallons of a 40% solution to obtain a 25% solution. Remember that usually the way I'll set the solution problems up is kind of like with a little diagram. And I'm going to look at my 2 buckets of solution, whatever they are, and I'm going to mix them together to create this new solution. So this is what it's going to end up equaling down here, this new solution. So what is it that I'm mixing together? Well, each bucket has to have 2 things. It has to have a percent of strength, and it has to have how much is there. So on this first one, it says how many gallons of a 15% acid solution. So my first bucket must be 15%. I'm going to write that as a 0.15. But the question is, how much of that am I supposed to be using? So I'm going to go ahead and put an X for how much of that. And it's going to be mixed with 4 gallons, so that's how much is in this bucket, of a 40% solution. So this is 0.40. I'm going to mix these together. Now you can tell that one is a lower strength, one is a higher strength. So if I'm going to mix them, I'm going to end up with some sort of strength in between those. And I want to get a 25% solution. So that's going to end up, I'm going to squeeze this in. I didn't make my buckets very big here. 0.25 right there. Now, usually what's missing is an amount somewhere. And so you just have to think through this. One of these amounts is not going to be cut and dried. It's usually a combination. So think through this with me. I'm pouring 4 gallons from this bucket. So I know there's going to be 4 gallons. Plus I'm also going to add X gallons. So together, I would have X plus 4 gallons in there. These problems all kind of set up the same way in that you're going to have these 3 buckets. You're always going to add the top 2 buckets, set it equal to the bottom bucket. It's just about a variation of where that X ends up going on these. Now, when we set up our equation, you're always going to multiply. So I multiply my percent times my amount, multiply, multiply. But if I take this plus this, it's going to equal this. Here I go. So it's a 0.15x plus 0.40 times 4 equals 0.25 times the quantity x plus 4. All right, so now I'm just going to work through the algebra on this. This is going to be a 1.6, distribute the 0.25, and that ends up just being a 1. I totally made up the numbers on this, so my numbers might not come out great. Yours might not come out great. That's okay. All right, so the next thing I'm going to do then is get my x's on the same side. So I'm going to take my x's over to here. I'm going to take my numbers over to there. So when I subtract that 1, I'm going to have a 0.6. Subtract 0.15 from 0.25 gets me a 0.10x. Divide by your 0.10. And x is ended up to equal 6. Okay, now think about what you found because you have to answer kind of like with the units or something. So x is representing how much of this 15% solution, which is exactly what the question was. So I'm done. I need to have 6 gallons of that solution. Okay, so now I've kind of practiced one. You need to do the one that's on your paper. You set it up practically the same way. You just use your own numbers. And then what you're going to end up doing is submitting then what your answer is. I have another mixture problem, but it's kind of asking something different here. It says Adrian wishes to strengthen a mixture from a 5% to a 40%. Okay, so that means I have a 5% solution right here. And I'm going to mix it with another solution, but my end goal is to get a 40% solution. And the question is how much pure alcohol. So when they talk about pure alcohol, that percentage would be a 100% or a 1.00 if you wrote it in decimal form. So keep that in mind. I have one here where it's pure alcohol. We've also done problems where I'm adding water, and that would be a 0%. Okay, so then what I want to do here is I want to add this to 12 liters. So I don't really know how much I'm trying to add of the pure alcohol, but I'm adding it to 12 liters of the 5%. I'm going to add these two together and pour them in to create this 40% alcohol solution. Can you tell me how much should be in the bucket here? How much would be the amount of the 40%? Should be x plus 12 because I'm adding the 12 and the x together. Okay, one more time. You're going to multiply each bucket. So, oops, going to squeeze in a 0 here. 0.05 times 12 plus 1.00. Of course, those zeros are totally optional there. Equals 0.40 times x plus 12. Okay, 0.05 times 12 is going to end up being, what is that? 0.6 plus. This is just a 1x or an x equals, and then I'm going to distribute. So 0.4, I'm going to get rid of the extra 0 here as I go, plus 4.8. All right, x is on one side, so I'm going to subtract the 0.4 over and end up with a 0.6x. I'm going to subtract the 0.6. When I subtract that 0.6 to the other side, oops, messing up stuff here, sorry. When I subtract 0.6 from 4.8, I'm going to have 4.2. And then I just divide. Man, I'm getting lucky here. These are actually coming out nice. And I'm going to end up with a 7. Now think about what we found here. X is representing how much of this, which was the pure alcohol, which is the exact question, how much pure alcohol? So I need 7 liters of pure alcohol to make this happen. Okay, so then you have to try that same idea with your problem. All right, so now I'm going to do a couple problems that have to do with those investments. And sometimes I do this different each year, but this year I did a table or like a chart, filling in a chart here. Change that to, okay. So remember, we have a chart. When you're dealing with money and interest rates, you're going to take the amount that you are investing, whatever that amount is that you're investing, and you're going to multiply it by your interest rate. That's your percent. I'll even write percent rate here. And sometimes you even have to multiply it by the time, because this interest rate that's given to you is always given over 1 year. So if you have a problem where you're going to invest for 2 years, then you would also be taking it times time, and then you'd be putting a 2 in for the time. Or if you're investing for 6 months, you'd be putting in a 1/2 because that's half of a year. Now, this particular problem doesn't have the time to worry about, so I'm not going to mess with it. And I'm just going to set it equal to then the money that I make ultimately. How much interest did I make on that? All right, so let's look at what we've got. It says they have a building fund. They're going to invest some money in 2 different ways, which is a smart thing to do. You kind of separate your money into different accounts. So they're putting one at 3.25% interest. That's an interest rate. So I'm going to call that option A, and I'll have an option B. So option A, I'm going to put 0.0325. Change that percent into a decimal. And then they put their other money in at 0.0545. Now, how much did they invest? This kind of varies on how I give you this information. In this particular example, I don't really know how much I put in either account. So I'm just going to say I put X in the option A. And then right here, it says that I put 3 times as much in at the other percent. So 3 times what I put in for option A. Well, 3 times that would just be 3X. And then remember how, and maybe I'll show this just with a little highlighter, we don't ever like do anything from the problem in this last one. This last set of boxes always comes from just multiplying straight across, multiplying straight across. So I'm going to have right here point oh, oops, got my decimal there, 0.0325x. And here I have, finally gonna get my calculator out here. I was doing some pretty good mental math on this. Okay, so I'm gonna take 3 times 0.0545, and I get 0.1635. Oops, got an extra decimal there. Undo. 0.1635x. Okay, so now what we always do is we look at how much money we made in each account and we add it together to get whatever they tell you your total was, which was right here, $1,400. So I'm going to take 0.0325x. I'm going to add it to the 0.1635x. Kind of looks like a T, but it's an X. And together, those are supposed to equal 1,400. All right, so I'm just going to add the two like terms together. All right, I end up with 0.196x equals 1,400. And then take your 1,400 and divide it by that value, that 0.196. Okay, so here's what I got. I got 7142. This answer did not come out nice. I'm just going to round it to 86 cents. So now let's look at what we have found and if we've answered the question. It says find the amount invested at each rate. Okay, so what I have found so far is how much was invested in option A. So I would write that amount of money at 3.25%. And then to find out how much I put in the other account, I'm just going to take it times 3. So take that answer times 3, and I have 21,428.57 cents at the 5.45%. Okay, so see if you can work through your problem with those same numbers and get your correct answers for that. Now, here's the second scenario. This is the another interest investment kind of thing, but it's a little bit tricky with some extra information in here. It says that Zelda inherited $200,000 from her grandmother, and she immediately gave 10% to her favorite charity. And then what was left, she invested at these different rates. So what's tricky here is that this 200,000 that she inherited, she didn't actually keep that full amount. That full amount, she gave away 10% of it. Now, there's a couple ways you can do this, and I've seen students do it both ways. You can either look at it like find out how much she gave away and then see what's left. Or some people say, well, if she gave away 10%, then she just kept 90%. And then they just find 90% of the 200,000. So either way works. I'll go ahead, 10% of 200,000. So to figure that out, you would just be taking 0.0 there's your 10%, and you're going to multiply it by 200,000. Can you do that in your head? Should be 20,000. And so she had 200,000, but she gave 20,000 away. So to see how much is left, she's just going to subtract the 20,000 from the 200 that she had. She's left with $180,000. Okay, so this is how much she's going to invest. Let's set up our chart. And again, we're going to got option A, we got option B. I'm going to undo that. I'm going to scooch over here, give that a little bit more space. And the percent interest rate, she had a 2.5, so I'm going to write 0.025, and a 4.5, so that's 0.045. And the amount she put in each, this works out a little bit differently than last time, because I actually have like this grand total of how much money she had. I didn't have that last time. She has $180,000. So I don't know how much she put in option A, so I'm just going to write X. But think about this, like pretend the X was 80,000. Let's say she put 80,000 in that account. Can you figure out just in your head how much is left to put into the other account? And then what'd you just do in your head to come up with that? And I'm guessing you subtracted. So what you're going to do is you're going to take your $180,000 that you're investing, and you're subtracting what you put in the first account. So I'm going to subtract X. And then that's my leftover money that's going to go in the second account. Okay, so again, those last columns, all you're going to do is multiply straight across. So it's 0.025X. And this one is a 0.045 times 180,000 minus X. And again, from here, we're doing the same thing. This is how much money she made in the first account. This is how much money she made in the second account. We're going to add them together to see how much she was actually investing in that first account to end up with the 1,350. All right, to me, that seems kind of low. I may have to tweak this. I told you, I just made up problems. Okay. All right, heck, I'm so sure it's wrong. I'm going to tweak it right now. Sorry. Let's go ahead. Instead of making that a 1,350, let's make it a 7,350. So I'm going to change that. Okie doke. So now what I'm going to do is I'm going to take this money here that she made in option A plus the money in option B should equal what she made total for the year. So here goes my equation. I'm going to go 0.025x. I'm going to go ahead and distribute as I go just to save some time and a line of work there. So distributing that, I've already typed that in, got 8,100 there. Let's see, minus 0.045x, and that's going to equal the 7,350. All right, so I've got some like terms. Let's just solve this little linear equation. The 0.025 and the negative 0.045, that would get me a negative 0.02x. And when I take my 7,350, subtract 8,100, that'd be $750. Okie doke. Divide by negative 0.02. Actually, that would be a negative 750, sorry. Divide by negative 0.02. Type that in. And I end up at $37,500. Okie doke. Then I look and see if she spent that much in option A. That's great, but we want to know each rate. So now I'm going to take 180,000 minus that and see how much went in the other account. And so I have two answers. So I'm going to say this is how much at the 2.5%. And she also put, actually, I'm going to let you do this one. Okay, put 142,500. at 4.5%. Just subtracting that from the 180,000. All right, now I just have one of these. This is a distance equals rate times time problem. Also did charts for these types of problems. Distance equals rate times time. So we did rate times time equals the distance. Just like last time, the only way I'm going to fill in the boxes for distance is by multiplying straight across. That does not come from the problem. So let's fill in everything we can. Carissa drove to her grandmother's house for a weekend visit. She averaged 50 miles per hour driving there on Friday. Okay, so I've got Friday. She drove 50 miles per hour. That's a rate. And she returned home on Sunday. So this is my Sunday trip. She was able to go a little faster. She went 58 miles per hour. And her driving time was 30 minutes less. Less than what? Well, less than it was on Friday. So, but I don't know what the time was on Friday. So I'm going to just call the time on Friday T. And this is a little bit tricky here. Notice that your rate, these numbers that I did were in miles per hour. So to say that it took her 30 minutes less, that is not going to be T minus 30. You have to do this in hours. So what do you think this really should be? It should be T minus 1/2 of an hour. That's what 30 minutes would be there. Okay. And so then to fill in the distance box, I just multiply straight across. That's a 50T. And then I'm going to have a 58 times a T minus 1/2. Now these problems set up differently depending on what's going on in the problem. My question is always, hey, does D1, or I'll call it DF, Friday's distance, does that equal Sunday's distance? Sometimes yes, sometimes no. In this example, yes, it does. However far she went to get there, she's going to go the same distance coming back. So this would be one of the problems where you just set your two distances equal to each other. So then you're going to have distribute your 58. And 58 times 1/2, half of 58 would be 29. Get your t's together. Going to subtract. That's a negative 8t. That got a little weird. Equals negative 29. And then you're just going to divide. Now, this does not come out nice. Sometimes they do. This one, like I told you, made up numbers here. What I end up with is a 3.625. Now, what does that mean? So look back at your chart. T represented the time it took her on Friday. And the question says, what is the distance between Carissa's home and her grandmother's? Okay, they're asking for the distance. This is not my answer. This is not a distance. This is a time. That's why I like to use T for time, so I know at the end what I found. Okay, well, so this is how long she drove on Friday, and she drove 50 miles an hour. So wouldn't her distance just be 50 times that time right there? So that's what you have to do. So this kind of has an added level to it. The distance is going to be 50 times the 3.625. And I get 181.25. Now I have a distance, 181.25 miles. Now I actually could have, if I wanted to, since the distances were equivalent here, I could have even put this time in right here, and this whole field right here would have given me that same answer. But obviously the first one would have been way simpler. Okay, so on this problem, I'm going to have you kind of work this with me. Again, I'm not giving you your exact problem, but I'm giving you one very, very similar. So what I'd like you to do, though, is I would like you to do your own numbers. I'm going to do my numbers. You do your numbers. All right. So here's what I've got. This is the amount of money in billions of dollars that the government spends on healthcare programs from 2010 to 2020. Okay. So you have this all written out. It says X equals 0 corresponds to 2010. And X equals 1 would be 2011, 2 is 2012, and so forth, so forth. Okay, so this is I don't feel like that's represented very well there. It is an annual expense. This is how much they spent each year. But as X starts to change, then the amount they spend would obviously change. Now, so according to this model, about how much was spent by the US government in 2017. All right, so what I'm going to do is a couple different options here. I could type this into my calculator to find it. I could do this algebraically. I want to show you really this problem. I think on your homework, I let you, or I mean on your test, I let you either do it algebraically or graphically. And I'm going to show you probably graphically. I would surprise some of you did choose to do this algebraically, but it's probably going to be faster in the long run to type this in your calculator. So what we're going to do is we're going to go into Y1. So you're going into your graphing calculator, pause the video if you don't have your calculator. You are looking at your paper and you are entering your equation, not my equation. Now, if I get to moving too fast and you need to stop the video, then you stop the video and get caught up. But go ahead and type that in. And then we have to fix out an appropriate window for this. So the window, X is your time, right? Corresponds to the years. So this went from 2010, which would be an X value of 0, to 2011. And I'm looking to predict 2017. So that would be an X value of a 7. But then I have to predict something farther in the future. So I'm just trying to think about what would be a good window. So I'm going to make my X min be 0. And then I'm probably going to go to like 30, just so that I keep it open enough to catch everything. I like to give myself plenty of buffer there. And so I'm going to just scale by 5s probably on something like that. Now my Y value is representing how much money they're spending in billions of dollars. So I'm just going to peek ahead a little bit at this second question. It says, in what year did the spending reach 350 billion? That's giving me a hint to sort of what to set my window up to. So I'm going to let my Y go from 0 to 500. Now that, not 500, I'm not going to add a bunch of zeros. I just know that it's in billions. And if I'm going to scale 0 to 500, I'm going to go every 50 probably. All right, let's hit graph. And what I am looking at, I'm going to show you, you should be probably looking at something pretty similar. On your test, I would always expect you to kind of give me a little sketch of what it is you're looking at. I know that this is a parabola. It's an x squared here, but all I'm really seeing is sort of like the right half of the parabola. And this is what I have if I went to 500 and I went to 30 here. That's what I'm looking at. So it says how much was spent by the US government in 2017. Now this we probably could have done algebraically relatively easily. It's the next question that I feel like we were going to want to have the equation for. So what I'm going to do is I'm going to hit second trace, and I'm going to go to value, and I'm going to put in the X value that corresponds to 2017. So remember, X equals 0 was 2010. So 2017 would be an X value of 7. So I just type 7, hit enter, and there's my answer. I have a 307.525. 307.525. Now, what I would like to do with that is go ahead and answer their question, but try to keep it as exact as possible. I could say about 307 billion, but why don't I go ahead and add in these extra values? So I would let you kind of go either way on this. You could say 307.525 billion. Heck, let's just do that. I think that's probably what your number looks like on your paper. I'm just going to do that. So my answer would be, and it says round. Oh, sorry, I should read the directions. Round to the nearest billion. So I'm at 0.5. So that's going to have to turn up to a 308 billion. Don't forget that word billion. That's a big difference between $308 and $308 billion. Okay, next question. In what year did the spending reach 350 billion? So this is actually a Y value, not an X value, because this would be what Y equals. It would equal 350. Now, what you could do, this is not factorable, so what the option would be was to try to do quadratic formula with that. All right, I would rather graph it. So I'm going to go to my equation, to my Y equal, and in Y2, I'm going to put what I want Y to equal. I want it to equal 350. So in Y2, I put 350. You're doing your numbers, remember. And then what you're going to get when you hit graph is a horizontal line coming through here at 350. And what you want to find is that spot right there where they cross. Okay, that's the intersection. So to find that, I'm going to do second trace again. Intersect is number 5. And then it's asking, you can see down at the bottom left there, it says, what's the first curve? They're asking you the intersection of what? Well, at the very, very top, it says Y1, and my cursor is sitting on Y1, and I just say, yeah, that curve. And then it automatically goes to my Y2, and because down there, it says, what's your second curve? Yep, that's it. Just press enter. And then it wants me to make a guess in case it's intersecting in more than one place. You can scoot your cursor over close to that intersection. And I end up with an intersection value for me, for my problem, is 9.58 is what I have here. 9.58, but let's read the direction. It says, in what year? Okay, so that means my X is a 9.58. That would be a 2019. Should I round it to 2020? What do you think? Nope. Even though the 0.5 would make you want to round up, it feels like it's still going to happen in the year 2019. It's just going to be kind of a little bit later in the year 2019. And so leave it at that value. Don't round up to the next year. Okay, so now you're submitting your answers to yours. You don't have to have my numbers. You have to have your numbers on this. All right, here is our last problem. And again, we're doing this together. The data is all the same, but I changed the questions, so my answers will be different than your answers. So you got to do the work, got to go through with me. All right, so this is the total amount paid by the U.S. government to individuals for Social Security retirement and disability insurance benefits. Again, billions of dollars. All right, so this is during the period from 2010 to 2016. And it says, let X equals 0 be 2010. We almost never, ever actually put in the year as the actual time. We pick kind of a starting point. So I'm going to put in a 0, 1, 2, 3, 4, 5, 6. I'm going to put that into my calculator. Now, this is a different type of situation. This is a scatter plot we're making. So I'm going to do a quick clear my RAM, second plus 712. That quickly gets rid of everything from that last problem. All right, so now this time I'm going to go to Stat, Edit. You got to do this with me. We're going to put in our numbers. So my X's, my list 1 is going to be 0, 1, 2, 3, 4, 5, and 6. And my list 2, I'm not going to add the zeros. I'm just going to remember it's in billions. And I just write the 705, the 725, all right, so it says use your graphing calculator to find a regression model that fits the data. Well, to find that, I needed to see what it looks like. So what I'm going to do is set up a window. So my window, if I look at my X's, it goes from 0 to 6, but I'm going to be doing some predicting, so don't get anxious to cut it off too quick. I'm going to go 0 to Um, I'm going to go 0 to 15. I lied. I might go to 20. I don't want to have to change it later. Okay, I'm going to leave my scale every one tick mark. And then my Y's, I'm going to go from, now you might peek ahead. I'm going to be predicting here when it is 2 trillion. Well, 2 trillion would be 2,000 billion because I'd have to have an extra 3 zeros there. So I am going to go from, I guess I don't need a big buffer on the low end, so I'm going to go 700. And then I'm going to give myself a little bit of buffer on the high end. I'm going to go 2,500. And I'm going to scale by 100s and hit graph. Oh, you know what? We cleared our RAM, which does automatically turn your plots off. So I'm going to go back to Y equals. That's kind of the shortcut to pop up there and turn plot 1 on. And then hit graph. Oh, okay. Yep. All right. What are you looking at? Remember, you should always be showing me a little bit what you're looking at. So to me, this looks definitely kind of a linear situation. This is what I'm kind of looking at. Now, I did open this up quite a ways. I went to 20 here. I went to 2,500 here. All right. So I'm going to run a linear regression. So we go to stat, calculate, linear regression. And it defaults to list 1 and list 2, which I want, but go to that store regression. And this is where we put in those keystrokes to make it copy and paste over into Y equals as it finds it. So we go to vars, Y vars, function, and Y1. Now, when I calculate it, it will tell it to me, but it'll also put it into Y equals with all the decimal values. Okay. So now we actually should agree with this. So I have, because our numbers were the same on this, I've got a Y equals, and my slope is 700, and I'm going to just round to 2 decimal places when I write it here. But when I'm doing my calculations, it'll have the full value. Oh, something looks funny on mine. Hang on just a second. I'm going to okay. Yeah, I had done the wrong linear, and it swapped my slope and my. I'm going to undo that. Sorry. Here we go. Y equals 37.32x plus 700.89. That's the linear equation. It says use the model to predict how much was spent in the year. Mine says 2024. So for 2024, since I started at 2010, my value is a 14, but yours would be different. So do yours. I'm going to go to second trace. I'm going to go to value. And I'm going to type 14. And my answer is, now think about this with me. I have 1, 2, 2, 3.39 billion, which I think seems kind of a weird way to write that. So I would be more inclined to back that decimal up 3 places and call it 1.22 trillion. That's what I would do, but whatever you do. All right, use the model to determine when it will reach $2 trillion. So now you're back to your Y equals, and in Y2, because now that's the Y value. I'm looking at the Y value being how much money there was. And $2 trillion is actually a 2,000 billion. So in Y2, I'm going to put 2,000. And it's going to make me a nice horizontal line through my graph. Uh-oh. So here's this, and then my horizontal line's up here, and they don't touch. That's a problem for me. So what I need to do, I thought I was being very generous with my 20. I wasn't. I'm going to go back to my window and I'm going to get crazy here. I don't want to have to do this again. I'm going to 50. So my X max is now going to be a 50 when I graph that, because I don't want to have to go find it again. Now it crosses and I can see it. So I'm going to do intersection, second, trace, 5, first curve, second curve. I usually just go boom, 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 hit enter, enter, enter through this. And what I ended up with for an answer then is 34.81. Let's think about what that means. 34.81 says find when. Well, that's has to do with my year. But remember, we started at 2010. So 34 years after that would actually be in the year 2044. And again, not going to round it to 45. It's just pretty late in the year that happens. That would be sorry, that's not dollars. That's a year. That's what year it is. All right. Of course, you're doing your own numbers and getting your own answers. All right. Hope this is starting to make better sense for you. Good luck.